Okay, so now cross product. We said this is a vector product because it returns a vector. Two ways of calculating it. One, again, if you have the length of the two vectors, it's their length multiplied by each other times the sine of theta. But that's really the length of the cross product. So the length of the cross product is the product between the lengths of the two vectors and the sine of theta. However, that doesn't give any information about the direction of the cross product. The information about the direction of the cross product is encoded in this unit vector, which is n, which is essentially only represents the direction of the dot product of the cross product result, because its length is equal to 1. If you want to calculate the full cross product vector, then the most common way is to use this matrix representation, where the first row is the unit vectors in the 3 dimensions, and then the two vectors go in the other rows, and you calculate the determinant. And we saw how calculating the determinant of this basically returns the vector. If you have the vector and you have your length, so if you have the vector and you have the length, by dividing the vector by its length, that's how you calculate n. Representing it, n is basically this unit vector here. It's oriented perpendicular to the plane that contains the two original vectors. And then the length of the full cross product depends on the result of the product. But we also saw that in absolute terms, the length of this product is equal to the area of this parallelepiped. Of this parallelogram. Basically, because this gray segment here is equal to the length of b times the sine of theta by construction. So by multiplying that, which is the height of the parallelogram, by the base, we obtain the area.